Okay, so here are the notes for section 8.4 trigonometry. Um, this is an important section for this chapter. We're going to spend a lot of time doing trig, so I'm going to do kind of a quick run through of the basics of it, where it comes from, and then in class we'll spend a lot more time working through it. But really, what this is for is working with right triangles, and this is to help us be able to solve missing lengths of sides using something other than SOHCAHTOA, because SOHCAHTOA is great. Or, I mean, sorry, not SOHCAHTOA, the Pythagorean theorem, because the Pythagorean theorem is great, but it only works if you know two of the three sides. And so, what if you only know one side? What else could you do to find the missing sides of a triangle? So, the first thing that I ask you about is, where does the word trigonometry come from? And it comes from two terms. One term is trigon, the first part, which means triangle, and metron in Greek, which means measure. So it literally means to measure a triangle. And a trigonometric ratio is the ratio of the length of two sides of a triangle. So for triangle ABC here, if I had the length of AC and divided by the length of AB, that would be what we consider a trig ratio. Now, the book talks about similar triangles, and that's what this is built around. So I pulled this up from the web, this little example here. And so the way this works, I'm sorry, it's just easier to go to this first. The traditional trigonometric ratio, there are three of them. Okay, there's sine, which is the ratio of the opposite side to the hypotenuse. There is cosine, which is the length of the adjacent side to the hypotenuse. And there is tangent, which is the ratio of the opposite side to the adjacent side. Okay, so I'll just sketch on this real quick so you can kind of, whoops, see something. I forget close this. Give me just a moment to open up my picture. Yeah, there's my family on Halloween. Okay, so anyway, here's this. Yeah, here's this drawing. So I got my trig ratios. Sine, again, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then tangent is the length of the opposite side over the length of the adjacent side. That's a definitional thing. It's how they're defined. Now the tricky part about this is that A and capital A and B, those are both angles. Okay. One thing was we never use the right angle. That's one thing people miss up. We'll never use angle C. You'll use that in algebra 2, not in geometry. But if I'm talking about angle A here, okay, the opposite side is the side directly across from it. So angle A, the side directly across from it, is side A. Okay. The hypotenuse always stays the same. That doesn't change any. And then the next side is called the adjacent side, and that's the side that's left over when you don't have the opposite and the hypotenuse, but it's the one next to the angle that's not the hypotenuse. So for angle A, this is the opposite, this is the adjacent, this is the hypotenuse. For angle B, though, that flips some of this, because for angle B, this side is the opposite side. Hypotenuse is still the same. That doesn't change at all. But the adjacent side now is this side right here. And again, a lot of times you see some people draw an arrow like this for adjacent and draw an arrow straight across for opposite. So this becomes the adjacent. And that's why for these trig ratios here, the sine of angle A is the opposite over hypotenuse. Well, the opposite of angle A is side A, hypotenuse is C, so A over C. But for the sine of angle B, the opposite is side B, the hypotenuse is C, so it's B over C. Cosine is adjacent over hypotenuse, so for angle A, the adjacent is B, the hypotenuse is C, so B over C. For angle B, the opposite is B, the adjacent is A, and the hypotenuse is C, so the cosine of angle B is A over C. And then the last one is tangent, which is opposite over adjacent. Well, for angle A, the opposite is A, the adjacent is B, and for angle B, the opposite is B, the adjacent is A. Okay, so that's the definition. Now, why do we care about all this, other than just, hey, do it? Well, somebody really intelligent a long time ago figured out that if you talk about a triangle, okay, it's not the side lengths that matter if it's a right triangle. It's actually the angle that matters here. And we're talking about this, it's angle A here, which is 48 degrees, 48.71. So this guy here is 48.71. Now this drawing here, ignore the circle part of it, that's not important. It's just to help out with the sketch. The angle here, no matter what I do at this point here, doesn't change. It just makes the triangle smaller. Now what that does do is it does make the sides bigger or smaller. But the opposite side for angle A is 1.32, the hypotenuse is 1.75, and 1.32 over 1.75 is 0.75. And no matter how small or how big, notice these ratios aren't changing. The only way I can change the ratios is if I change the angle. And that's what somebody realized. They said, oh, well, hey, if the angle is in this case 48.08 degrees, which is what this angle is, the opposite to the hypotenuse is always 0.74. The adjacent to the hypotenuse is always 0.67. And the opposite to the adjacent is always 1.11. It's just something that someone recognized. So we are going to use that information to solve for missing sides of triangles. Okay? So that's the real power of this. And again, in class we'll look through a lot of examples. I'll do at least a few here in class now, or in the video now, but we'll spend a lot more time with this. But the big part just to know is this is memorization. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent's opposite over adjacent. Okay. All right. So yeah, so here we go. I'm gonna have a little quick question pop up for the video, and then we'll do this one. Okay. All right, so here's the first example. It's asking us to find sine k or sine j, cosine j, tangent j, sine k, cosine k, and tangent k. And then it says round each decimal to the nearest hundredth. So I'm going to need my calculator out, and I'll go to the drawing now. Okay. Oops, of course it's right in the way. So we'll come back to that. So for angle J, this is the opposite, this is the hypotenuse, this is the adjacent. Okay, because again, opposite is directly across, adjacent is next to, hypotenuse is always the biggest one. So the sine of angle J is opposite over hypotenuse, so 5 over 13. The cosine of angle J is adjacent over hypotenuse, so 12 over 13. And the tangent of angle J is opposite over adjacent, so 5 over 12. Now if you want to know what those are as decimals, I just go to my calculator real quick and I do 5 divided by 13, which is 0.38 to the nearest hundredth. A lot of times we'll go to 4 places, but they only ask for the nearest hundredth here. 12 divided by 13, which is 0.92. Okay. And then 5 divided by 12, which is 0.42. Okay. Now the next part of this then is to do sine of angle K, cosine of angle K, and tangent of angle K. Where here's angle K. That's now the opposite. This is now the adjacent. So sine is opposite over adjacent. So the sine of angle K will be opposite over hypotenuse. The cosine of angle K is adjacent over hypotenuse, so it'll be 5 over 13. And the tangent of angle K will be opposite over adjacent, which is 12 over 5. Now, the nice thing is, I already have 2 of these values. 12 over 13 is 0.92, 5 over 13 is 0.38, and then 12 over 5 is 2.4. It's actually 2.4, 0 to the nearest hundredth, but 2.4 works. Okay, so yeah. Now, the next thing in this section is not just finding these ratios, but using them to find missing side lengths. Okay. And this is the big emphasis for this section, finding these missing side lengths. And it's not terribly hard to do, but you do need a scientific calculator. So here's how the process works. Okay. Supposed to find the measure of x. Now they give me an angle, so I'm going to use the angle they give me. For this angle, x is the opposite side, 18 is the adjacent side. So what you have to ask yourself is, out of these three functions, which one relates adjacent and opposite? Well, when I go through and look, hey, tangent is the opposite over adjacent. So the tangent of this angle has to equal the opposite length over the adjacent, which is x over 18. Okay. So that's the equation we set up. I know opposite, or I'm looking for opposite, I know adjacent. Tangent's the one that sets it up, so it's the tangent of the angle, and that's always what we're taking, tangent of, or sine of, or cosine of the angle. Now you might say to yourself, okay, great, I set up an equation, but what does this do for me? Well, here's also where the calculator's super nice, because I can do tangent of 25 degrees in my calculator. Now, if you're using a graphing calculator, make sure you push the mode button, okay, mode, and then make sure it says degree here. If it isn't highlighted on degree, if it's highlighted on radian, which it actually normally is set to, you have to scroll over to degree and press enter. Okay, my angles are in degree mode. I have to be in degree mode in the calculator. You'll learn about radians in Algebra 2, so don't worry about that for now. So I can, in the calculator, take the tangent of 25 degrees, and I get 0.46630766582. The easiest way to do it is just to go to the first four digits. So the tangent of 25 degrees is actually 0.4663 equals x divided by 18. Now to solve for x, then multiply both sides by 18. That'll cancel it off. So what you can do then is just do 18 times 0.4663, or in fact, if you just want to do times 18 now, it doesn't really matter. I'm going to get 8.39 to the nearest hundredth, so 8.39 equals x. That's the value of x. Okay. Now, just to check this, just to kind of get into what we're doing here, remember I did the opposite over adjacent, I did tangent. If I take 8.39 and I divide it by 18, I get 0.4661111. That's pretty close to the 0.66307 whatever. So that's what we're saying, is that the ratio of the opposite to the adjacent should be this if it's 25 degrees. Well, when it was 25 degrees, I got x to be this. Hey, look, those guys are pretty close together. Okay, so let's try another example. 3b. Okay. 3b. We are looking for, and I'll clear you out and put you away for a moment. Okay, so question is going to pop up in a second. It'll ask you, which trig function do you think you should use to solve, and then I'll walk you through the solving. Okay, so we're back. Okay. So looking at, change color because the marker's getting a little dry. Here's the angle I have, 70 degrees. Okay, x is the hypotenuse. 15 is the adjacent side because this is the opposite. So I say to myself, okay, which trig function uses hypotenuse and adjacent? Well, if I go back to that sheet, which one uses hypotenuse and adjacent? That's opposite and hypotenuse. Adjacent and hypotenuse, that's cosine. So in order to solve for this side length here, I'm going to have to use cosine, which is adjacent over hypotenuse. So the cosine of this angle equals the adjacent length over the hypotenuse. Now this is the one that's actually a little harder to solve algebraically, and to be honest, I kind of jumped the gun in the last one. I really should have done the solving first and then threw it in the calculator. It's easier to do that way, but I just was kind of showing you the process. So especially when we get to algebra 2 or on the ACT, they won't leave it, they won't throw it in the calculator first, they'll throw it in at the end. So to solve this, the first thing I have to realize is, hey, I'm dividing this guy by x. So multiply by x to cancel it off, and whatever I do to one side, I have to do to the other. So I get x times the cosine of 70 equals 15, and then to solve for x, divide by the cosine of 70 degrees. Okay. And now I get this answer. X equals 15 divided by the cosine of 70. And again, on the ACT, this is what you would see. It would say solve for x, and then this is what the answer will be. Okay. Now, to find what that is as a decimal, I just simply say, okay, take 15, divide it by a cosine of 70. Again, making sure we're in degree mode. And I get 43 point, what did it say? 43.86 if I went to the nearest hundredth. $43.86. Okay, so hopefully that makes sense. All right, now the last thing to cover for this section, okay, last thing to cover is the inverse trig functions. Okay, let's go to my big thing of this. Inverse trig. Now, the way this works is that, for instance, I know the tangent of 0.58 if I do tangent at 30 degrees. Okay, tangent 30 degrees. It's 0.577350 and some change. So it's about 0.58. The question that comes up next is, okay, if I can find the tangent of an angle, what if I knew the ratio? Could I work backwards to the angle? And the answer is yes. And that's what these inverse trigonometric functions do. So it's called inverse sine, and what it looks like is it has this little sine to the -1. And that means inverse sine. Inverse cosine is cosine to the -1. And inverse tangent is tangent to the -1. And what they do is you plug in the ratio right here, and for x, doing this guy on the calculator, it gives you the angle. So they're really easy to do. It's really a matter of the calculator more than it is by hand much work. So for instance, real quick, I want to do inverse tangent. Well, if you look on the calculator, you'll see tangent -1 up there. If I do second tangent and then plug the ratio in, 0.5773 and stop, whatever, or 735 and stop, I get almost 30 degrees. So it's telling me, oh, if you had tangent and this was your ratio, you work backwards, there's your angle, almost 30 degrees. So let's look at an example. Again, they said these are really quick to do. It's just a matter of more making sense of what the heck is going on. So here's 4a from the book. Okay, I'm looking for angle A. So what you have to do, again, either mentally or physically, hey, I'm looking for angle A. Well, what sides do I have? Well, I have 6, which is the opposite. I have 20, which is the adjacent. So you say to yourself, which one does opposite and adjacent? And hopefully you would understand by now it's tangent. So here's the kind of work right out part of it. The tangent of angle A is 6/20. Well, I want to know, I know the ratio here. I want to know the angle. So that's where I do inverse tangent. That, given the ratio, will give me the angle. So go to the calculator. Second tangent of 6 divided by 20, and I get 16.7 degrees. It says nearest tenth. Yeah. So the measure of angle A equals 16.7 degrees. Okay. All right. So let's try one more then. Just one more problem. Again, I know this video is running long, but just one more example. You can see how quickly those were. So here's problem 4b from your sheet. We're solving for angle A again. Solving for angle A again. Okay. So the question is, and it's going to pop in the video, is which trig function would I use to set up for angle A, and then leading to me to which inverse function would I use? Okay, so hopefully when you looked at this, you recognized that 15 was the hypotenuse, 3 was the adjacent. So which one uses hypotenuse and adjacent? Well, that's cosine. Cosine is adjacent over hypotenuse. So the cosine of angle A is the adjacent side, which is 3, over the hypotenuse, which is 15. Now, in order to solve for angle A, That's where that inverse function comes into play at. 3 over 15. So get the calculator out. Second cosine, that pulls up that inverse cosine. Okay, 3 divided by 15. And I get 74.5 to the nearest tenth. So that's the measure of this angle here, is 74.5 degrees. Okay. All right, so I do apologize. We went 20 minutes on this one. I tried it the first time, it was 22, and I'm flying through it this time. So, sorry that it went so long. So I'll see you in class. Have a good evening.